I've got the formal definition for a two-sided finite limit up here on the board here, okay? And I've sort of underlined 4 key parts. So the definition is that for every epsilon bigger than 0, remember that's our standard of closeness or our tolerance for our y values. There's a delta bigger than 0. That's our standard of closeness or our tolerance for our x values. Such that if this inequality tells us that the distance between x and a is small, using our delta as our standard of what counts as a small distance, it also tells us that x isn't a, that the distance is bigger than 0. Okay, so this says that x is close to but not equal to a, using delta as our standard of closeness. And then this inequality says that the distance between f of x and L is small, using epsilon as our standard of closeness. Okay. What we're going to be doing in the next couple of videos is modifying this basic definition for some other types of limits. In this video, I want to talk about one-sided limits. In particular, we're going to talk about limits coming in from the right, and in the check-in assessment that you do online, you'll actually see if you can modify it for the one-sided limit coming from the left. Okay. Then we're also going to take a look at infinite limits. Okay. So we just need to tweak the definition again, but it's always going to have this basic form. So you can see what I've done for this one-sided limit, even though we haven't stated the definition, I've said it's going to basically have this same form. For every blank, there's a blank, such that if blank, then blank. And we've got to fill in those 4 blanks. Now the first 2 blanks introduce my variables. They introduce these 2 variables that are being our standards of closeness or our tolerance for the x and the y values. And then my second 2 blanks are filled in by inequalities that say that our x values are close to a and our y values are close to the limit. I also want to point out that in talking about the limit, if we say the limit is L, we are talking about the y values of our function. We're saying the y values get close to L. Okay? So this first blank here and this last blank here are talking about the y values. This is my standard of closeness for y. This says that my y value is close to the limit using that standard of closeness. The middle 2 blanks are about the x values. Because how do we ensure that our y values are close to the limit? We do that by making sure that our x values are close to the number that x is approaching. Okay. So we're going to have that same basic setup here. The first 2 blanks are going to be introducing variables. The second 2 blanks are going to be inequalities. And we're going to start and end talking about y. And we'll be talking about x in the middle, because if we can control x, y will do what we say y is going to do. Okay. So if I look at what we have to modify if this is a one-sided limit, I can pretty much get for free 2 of these blanks, because I'm not changing anything about what I'm saying about y. I'm still saying that f of x is getting close to L. So I'm still going to have an epsilon as my standard of closeness or my tolerance for the y values, and I'm still going to be trying to say that the distance between f of x and L is smaller than epsilon. The difference is in my x values because we're approaching just from the right. So over here I've drawn a picture of a function where the limit from the right as we approach a is L, but I purposely made it so that the limit coming in from the left was a different number. Okay? Because ordinarily with a two-sided limit I would just say I want to be close to a. But close to a could involve being to the left of a, and I don't want that. I want to be close to, but on the right side of a. So if I just look at my number line, if here's a, x is going to have to be to the right of a. Now, that means that the distance between x and a will simply be x minus a, right minus left. I don't need an absolute value. I needed an absolute value if it was possible that x was over here so that I didn't know which was my right endpoint and which was my left endpoint. But here I do. I can say the distance between x and a is just x minus a. Excellent. And I want x to be close to a. I'm going to, again, just introduce a standard of closeness, a positive number delta, and then this blank is going to say that x is close to, but not equal to a. 0 less than x minus a, less than delta. No absolute value, because if x was over here, x minus a would be a negative number, and now this inequality isn't satisfied. Another way I can look at that is that if here's a, if delta is my standard of closeness here, this would be a plus delta. I want to have a picture that looks something like this. So I basically want to have that a is less than x, which is less than a plus delta. X is in between a and a plus delta. So it's to the right of a, but it's to the left of a plus delta so that it hasn't gone too far away. Now, if you wanted to use this inequality here instead of this one, it's totally fine because they're equivalent. Notice if I just subtract a from each one of these pieces here, minus a, minus a, minus a, what I get is 0 is less than x minus a is less than delta. So they're equivalent ways of writing the same thing. Excellent.